Hi, welcome back to the Unit 1 Notes. I'm Dr. Gary Bedicher, and let me pick up where we left off and talk about the UML background. And UML, actually, the way it came about was there were different object-oriented standards, methodologies that existed in 1980, 85. There was one associated with programming language called Ada by Grady Booch. Then in 1990 to 95, the OMT was published, and that dominates the market and gets a lot of traction. And then what happens, there became awareness that, and this was created by Rumbaugh, the OMT, there became awareness that, did I mention objectory? I don't know if I did it. Anyway, there were three different standards that were emerging, and Rumbaugh, who created the OMT, Jacobson, who created objectory, and Booch, who was at Rational, they realized in 1994 and 95 that we have a problem because there's three different threads going on, and they need to merge those threads. And so they came up with the UML, the Unified Modeling Language, in January of 1997. Now, why is it unified? Why is it modeling? Why is it a language? It's unified because it unified the standards from Jacobson, Booch, and Rumbaugh, as I pointed out, and accepts accepts concept from different OO methods, applies to most domains like financial or oil and gas. It's language platform independent, and it works with any process. You have the spiral model, waterfall model, and so forth. A modeling aspect, it's common among all engineering, or modeling is common among all engineering disciplines. It captures major aspects of a system and leaves out details. It helps stakeholders understand the system and where it might be going, and it provides different perspectives by the different diagrams. As from a language perspective, it's precise and unambiguous language, and handles graphical as well as well-defined semantics, and it allows both forward and reverse engineering. So UML, that's the Unified Modeling Language. The components of UML are they're actually shown here in this diagram, and this can be a confusing diagram. There's like three levels. There's the structural level here. The middle layer in gray is showing behavior, and the we have, well, maybe I'm reading backwards, sorry. And the top layer, sorry, is the semantics, like how you might implement it. That's the behavior, and that's the structure. This diagram might be a little confusing, so let's come over to another perspective. UML can be broken down. They're different components, and they're either structural or behavioral, but not both. Structure focuses on how things are organized, structured. And for example, if I say a person, how they're structured, I might talk about things like their height and their weight, eye color, and so forth. Behavior, I could say something like, oh, this person's a nice person, or they're a very angry person. So it's more of an internal type of thing as to how something behaves. And regarding UML, structurally, class diagrams come in the category of structure, component diagrams, composite, deployment, object package, profile. These are all static or structural. Dynamic or behavioral, they include things like activity diagrams, state machines, use cases, and then interactive diagrams, which break down to communication, interaction, sequence, and timing. Now, sometimes you'll see overlap between some of these diagrams, like especially in the behavioral, and we'll be focusing on the ones that are more commonly used. So for example, we'll see class diagrams. That's one of the first things we'll look at. And then we'll see use case diagrams. We'll have activity diagrams, sequence diagrams. And if you go over the syllabus, you'll see the list of things we do. Ones that maybe are perceived as not as important are in the what I call other diagrams area. Now here's another view of the UML in terms of structure and behavior. This is just more of a graphical representation of what I just went over. And there's a paper which is on the Google Drive called How UML Diagrams Are Used. Please read that paper at this time. And I wanted to mention something, UML equals napkin scribbling plus plus. Now what do I mean by napkin scribbling? Well, it literally means, okay, if I have a napkin here and I'm with a bunch of people and we're trying to figure out something, we might scribble on a napkin like at a restaurant. The founder of Southwest Airlines, Herb Kelleher, he actually was in a restaurant and they sat down and they identified 3 cities for Southwest when starting out: Houston, Dallas, and I believe San Antonio. And so from there it launched into the whole Southwest Airlines Corporation. Now, when interesting quote from Grady Booch says, when Jim, Ivar, and myself began the UML, we never intended it to become a programming language. I think it's a fairly narrow domain, and most diagrams should be thrown away, but there are a few that should be preserved, and one should only use a graphical notation for those things that cannot easily be reasoned about in code. And so, as I've often said, the code is the truth, but it is not the whole truth, and there are things such as rationale, cross-cutting concerns, patterns that cannot easily be recovered or seen from code. There are things for which graphical notation adds value, and any notation should be used only if it has predictive power, reasoning power, and you can ask questions about it. So part of what happens is I want to have it so that as you learn the different components of UML, it can add value, make you a better programmer, and that's one of the intentions of having these diagrams. Now, for next time, read chapters 1, 2, 3, 5 in the UML Distilled. Also review the following links, which you can find on the Google Drive in terms of these papers, class diagrams. Also read Unit 2 notes, and take the corresponding quizzes as specified on the online syllabus. Well, what I like to do at the end of a set of notes is to have some quotes. Hopefully they'll inspire you to be a better person. One of which is from Michelangelo, that the greater danger for most of us is not that we aim too high and miss it, but rather we aim too low and reach it. Sometimes we set very low goals for ourselves, like, oh, I just want to pass this class. Well, try to set the goal to get an A for the class and motivate yourself to work harder. Your life is in your hands to make what you choose of. No one can drive your life, only you. Let others lead small lives, but not you. Let others argue over small things, but not you. And let others cry over small hurts, but not you. Let others leave their future in someone else's hand, but not you. So I thought that was some very good quotes. Finally, there's review, questions, and exercises. And so based on what we've said, you ought to be able to answer all the first 4. Number 5, go to the internet and search for trends in software development. How many projects are created per year? Also find out what's the annual budget for a software project. Be prepared to discuss this in our next class, which is hopefully we'll have next Thursday. So thanks a lot, and that wraps up the Unit 1 notes, and I'll see you Thursday, September 7th, I believe. Okay, bye-bye.